Hello, everybody. Welcome back to another forecast. Today, we're looking at our severe weather potential for today and a little bit of tomorrow, as well as just information about Tropical Storm Debby, listed right here on the National Hurricane Center page. We'll also just be taking a look at the whole pattern that we have going on and what could be coming for the future. So, regarding severe weather potential, right now, today, this is our current day one outlook. It's 10:43 Central Time, so I still have about an hour until the next outlook comes out. So this could end up outdated by that time. However, as of now, we have a 5% risk for tornadoes down here with Tropical Storm Debby, as well as a 5% up here near the Minnesota, Iowa, and Wisconsin borders. 2% also going a little bit into Illinois, and then a little bit of a marginal risk up here for tornadoes up in the Vermont and New Hampshire area. So regarding Tropical Storm Debby, we'll start with that. Basically, this system is just kind of moving through here. I think we can get our past track, but essentially it kind of came from down here near Cuba, way down in the islands, took a turn here, had a brief area of hurricane force winds right in that little curved area right here, right around where it is right now, actually. And then it has weakened since then to a tropical storm, likely a depression later on. This is a very slow moving system. And one of the most important parts about this is the fact that it's going to be dropping a lot of rain. Here's our rainfall potential. This is upwards of at least 20 inches almost is forecast. I think it's over 5 days in parts of South Carolina, but widespread at least 8 inches of rainfall. So we're gonna be seeing a lot of rain with the system, especially because of how slowly it's moving. Same thing here is excessive rainfall. That's just again how much rain is falling. The high risk for this whole area. A lot of rain is falling at the moment. I believe some of measurement are already quite high. This is the chances of tropical storm force winds. Again, same thing. Right now, it has that tropical storm strength. However, as it weakens out, it's likely it's going to tropical depression. Could still bring a tornado risk. But regarding tropical storm Debby with tornado risk, that's basically just because of how strong the low pressure is. If you look over here, we'll look at the RAP model. The NAM is often quite unreliable with tropical storms. You can see this is a very strong low pressure system with 17 knots plus surface winds all around it. That's bound to bring at least a few rotating updrafts. I'll take a sounding from right here near the center because there's currently a tornado watch out for this region, but over the entire area there is definitely that tornado potential because of that shear. It also means that the storm as a whole is kind of getting sheared out as time goes on. You can see at all levels of the atmosphere, especially 850 there's lots of shear. Here's your photograph. You can see plenty of curvature all over it. However, one thing would always be the cape. There's not all that much cape, but the amount of forcing in the system, any updrafts that are able to rotate might produce weak, short-lived tornadoes. That has been talked about through the SPC page. It's just the fact that there could be so many widespread tornadoes, kind of all over here. Where's the information for? Yeah, information's right here on this page. Basically, just low-level flow being stronger, and there's the possibility for a few tornadoes with the stronger up. Now, regarding this area up here near Minnesota, that has to do with a different system. If we look back at our 500 millibar level, you can see a pretty well-defined high pressure system right here. See all the kind of clockwise flow. It's not very circular, so it's not a super strong one. It's kind of bananaed out. You can see there are low pressures up here with the main flow regime here being our low pressure tropical storm Debby. But the main thing is there's low pressure up here, and the high pressure here is dampening a lot of storms for our typical area during the summer. However, in regions up here, you end up with a lot of shortwave troughs, as the little troughs that like to form off here out the Rockies, they try to fight this high pressure. You can see here we get enhanced flow occasionally. You can see a little bit of a shortwave trough is at 700 millibars right here. I would say it's placed right here. You can see that curvature in the contour lines here, stronger flow ahead of it. That is actually what our main forcing is for our Minnesota today. We will go to the Midwest sector just because the broad area. I think the risk is somewhere. The risk area is kind of right here. That's our main area of interest. We look closer to the atmosphere as well, and 50 millibars. Not super strong flow, but we do have, and that is more confined to the Minnesota region. So while it's not super strong, it's only hitting about 21, maybe 30s knots. so from 20 to 30 knots of flow. That's a little bit something that could help with storms. If the surface map, you can see a pretty well defined surface low right here. You can see the rotation around it. And right here is where I would center that, but you can see southerly flow, more easterly flow, more northerly, and you can see the flow rotating around as you would expect the low pressure system. This is bringing up that moist air. Moist air is definitely coming up into this. You can see it right here in the dew points. Widespread 70s dew points. And one interesting thing to note as well is a higher moisture out here in the Illinois region, which we'll get to in a second. Right now, I'm going to look at the reflectivity that comes from the HRRR. This will help to kind of understand what these storms are going to do. You can see underneath all of this, these little arrows, that's our surface map. And you can see back here, there's our surface low. Ahead of this line, you get lots of formation, that open warm sector of the atmosphere. And then as you go on, you can see kind of more by the warm front, but you can see these stronger storms definitely forming right there along that warm front. And where you get colder temperatures up here, but warmer down here. Right along that boundary right here, that's where you start getting those storms to form. A little bit of better moisture, and that's where our storms are really going to fire. The soundings, you can kind of see the atmosphere, and I'll explain what it looks like. It's on these tabs right there in that open warm sector. That's where we saw those storms. You can also take a sounding from this HRRR, so we'll do that as well. This is the 14Z run, so they're a little bit different, but basically the same thing. This one's also one kilometer, so closer to the ground. Take a sounding ahead of this line as well. We'll do. Here's our sounding for that right there in Minnesota, and it's a very good photograph, almost very mothership like. So when you end up with a photograph that has central point and then all around it this very circular, like a semicircle, but for the most part it's very even and widespread. You could see some very nice mothership supercells coming out of the system here, especially if they're discrete. There definitely is also tornado potential. You have very good curvature in those lower levels, as well as basically LCL is within the first kilometer. Recape is at 73, so not super high, but it is definitely enough to warrant tornadoes forming. But also surface vorticity, as we saw right here, that's also somewhat high. Yeah, you can see a pretty nice maximum right here. So higher surface vorticity, and there is some 3 cape in that region. Not super strong, but with the amount of forcing, it could end up being better for those tornadoes to form. Here's another sounding from the HRRR. Basically the same thing it's showing. This was taken in that same risk area, and you can see that very nice curvature in that photograph. Very semicircle like. Let's go back to the HRRR here as well. Unfortunately, the NAM is not working, or the NAM NST, which I like to look at occasionally, is not working here for sounding. But you can see also reflectivity over here. The 12C NAM. You can see right there around the same time as these storms are firing, you get another kind of prefrontal boundary here as well. These colder temperatures here, but warmer down here. So with this northerly flow, you end up in this little bit of a convergence band, I would call it. Just an area of convergence that could start to fire some storms. And I don't believe the NAM NST will allow me to take sounding. Oh, maybe it's fixed. We'll see. You can see there's some higher dew points here as well, so better moisture for these storms. It'll also be hotter, but if the storms, they have the better moisture, they'll be along that boundary as well. We'll see how that could help. And back to the HRRR here again. Similar to up in the Minnesota region, you have that kind of bullseye, but not as strong of surface vorticity. Oh, the name is actually giving us soundings now. So see this sounding, a little bit of curvature there. Yeah, not amazing for supercells. You can kind of imagine this as a mini supercell. A little bit of curvature, and then a little bit of backing here in the mid levels with a bit more setting off. Not the best photograph, but it gets the point across, and they could have some mini supercells. As well as if you look here, right here, 83 over 79. That is our temperature dew point spread, and that's pretty good because that means any storms are very surface based because of how close these are together. Air parcels get condensed, or they get moisturized very quickly, and then they rise because of that on that saturation adiabet. About 4,700 joules of surface based CAPE, lower in the mean layer and much lower in the effective inflow layer, but at least 3,000 joules per kilogram seems very plausible. Like the CAPE here, the NAM is probably doing NAM is doing CAPE a little more excessively. See the difference here. Here's the name NST, and these are capes reaching over 4,000 at the mean layer, whereas the HRRR is not seeing nearly as much ability. That is something to note. I did forget to open the HREF. Hopefully this has the 12Z run out as well. We're going to be checking the updraft velocity to see where our rotating updrafts might be. Open up that probability mode. You can see here, back in Minnesota, it's definitely the much more probable mode for rotating updrafts. However, ahead of that line in that northern Illinois and kind of that very southern Wisconsin area, that also has a small probability of some rotating updrafts. You can see here a little bit of a 10%. HRRR shows one or two making their way out of there, but for the most part, these storms are more confined to the Minnesota region. That's definitely the bigger threat. That's why I got that 5% way up there, and kind of this more elongated 2% somewhere in there. Lastly, I'll look over here at the northeast, and then also I'll take a look at the day 2 outlook. This is a minor wind and hail, slight risk of wind and hail out there in Montana, so we'll look at that in a second. Regarding our system up here in the northeast, look back at the 500 millibar level, and you can see here that trough I noted earlier is more like neutrally tilted right here. You can see how the flow is not, it's not like this so much, which would be a positive tilt. Also not like this, which would be a negative tilt. Right in the bottom of that trough, and that leads to enhanced flow, but also more of a linear regime because of it, I would say. We'll go down to 700 millibars, like short waves, we don't see anything. I'm waiting some more enhanced flow, so that might be our main forcing, is just stronger flow aloft. And at 50 millibars, you can see that curvature a little bit more north towards the northeast, so more southwesterly, which might help supercells if they were to form. And then here's the surface map. We don't really have amazingly well-defined surface flow. You can see a little bit more of a circular flow right here, possibly a surface flow trying to form, more southerly, and then more kind of messy. There's not much flow at all, but you do get a little bit of enhanced southerly flow coming into this area. Like sounding right here in Vermont, right at 23Z. We'll see what we're looking at. Dew points also going into the region, mid 60s. Cape wise, not super widespread cape either. However, I think 3 cape is the main issue. Yeah, you can see here over quite a bit of 3 cape, and surface vorticity coupled with 3 cape, and that can help you tornado threat. You can see here even this is our Vermont sounding, I believe. That right there in the Vermont New Hampshire border. See, there's your curvature in the lower levels, and kind of this jetting off of wind as you go up. So kind of interesting photograph, as well as 112 joules per kilogram of 3 cape. So that's your tornado threat, but you can see for the most part this is a unidirectional wind shear. Apart from these lower levels here, most of this wind is just to the east, and that's where that wind threat comes from. I'm a little bit not understanding why there is as high of a hail threat. The 15% hail threat seems somewhat excessive, but it could just be because of the large forcing that could lead to stronger updrafts. Also, with this 15% hail over the Minnesota regime, you can see on the HRRR, you can see how strong these updrafts were. I mean, right there, you can see all those little kind of bowing line segments here, maybe. Yeah, little bow echoes. That's the HRRR is depicting, but stronger updrafts and little bow echoes could lead to more of a hail and wind event, but tornadoes are definitely not out of the question. As I said, we'll look at the day 2 outlook as well. Let's look over here at Montana. Go to the cone, the NAM here, because it goes out a little further. Here's 500 millibars, and for tomorrow, see there's that high pressure, however, slowly again moving to the east, and you can see the low pressure forming a little bit here. Not super well defined again, but you can see those little waves as the air tries to fight against this high pressure. Kind of gets this curvature right here and stronger flow right here. So I'll see if we can get any activity out there. Yes, you can see lots of storms firing right there on 21Z. Very all over the place, but I think the threat here is just a few of these congeal. They could lead to that more marginal, slight possible risk here. They all congeal. You can see kind of a possible Boeing line segment right there. Here's the NAM with a little bit more convection forming. A few of those hail's probably the main threat if anything. See that wind damage threat larger, but I feel like the hail is probably the main threat with this system. Tornadoes, likely not. Let's take a sounding just in case, though. Take a rap sounding. One of the other soundings. I'm a huge fan of soundings. Best. I'll take a NAM sounding from right around that same place. Let these load real quick. Yeah, definitely more wind look. Very inverted V. However, we are also at the higher elevations out there. Let's see if it's more on the west part actually. So we'll take one right here as well. See what the more east, more to the east. Yeah, the NAM here is not giving me soundings, unfortunately. Let's take a regular NAM sounding. Get more out of the east portion this time. Yeah, unidirectional here for sure. It's stronger as you go higher up in the atmosphere. So possibly some more stronger updrafts. Here's the NAM with a little bit of curvature. Stranger looking photograph, but it's the most similar thing. It's just the fact that their winds are getting stronger as you go up in height, and the fact that the temperature do spread. We're at the higher elevations, and that leads to much higher base convection. So that's your hail and your wind. And because of that higher base convection, tornadoes are not really in the picture here. So otherwise, I don't really have much else to say about all this. Tropical Storm Debby will then move off to the northeast, but it is weakening at that point. All these marginal risks are not, I'll look at them in my own time, not in this video. So with everything, thank you for watching. If there are any updates, I might post on the community post area. Maybe even get some footage if I can. But with that, thank you for watching. I'll see you next time. Goodbye.